In this video, we'll be talking about what is measurement and instrumentation. So let's get on to it. Basically, what we're trying to do within measurement instrumentation is trying to quantify a physical variable. Now, there's lots of different physical variables around, everything from distance to temperature to weight to voltage, plenty of them, and we'll be talking about lots of them in a fair bit of detail. Historically, we've used these in a few different areas. For example, in trade, when we're selling spices or flour or something like that, and we're working out how much, what's the quantity of it that we're trying to sell. And then in building and construction, look at the pyramids or any ancient buildings or older buildings. Well, obviously they needed some way of being able to measure things so they can build them accurately. Now, in our modern days, we use these, of course, but we've got a whole lot of different approaches, different reasons we use measurement. For example, in precision manufacturing, where we're trying to build very fine things. In our control systems, where we've got our, for example, our climate control within our car, where the heater turns on if it gets too cold, or air conditioning turns on if it gets too hot, all of those sort of things. In our homes, we have those climate control things. We want to, when we're doing our cooking, we want to measure the quantity of flour or oil that we're using. So all different aspects of measurement systems within our homes. Our transport systems as well. When we've got our car, we've got a whole lot of measurement happening within our car. Everything from using it for locomotion, and we want to work out how fast we're going so we don't get booked, through to our safety systems and our anti-lock braking, working out whether we're slipping, deploying airbags, all sorts of different areas we use measurement and instrumentation there. And, well, pretty well everywhere else we use it in lots of different parts of life, both in engineering and out of engineering as well. Now, we should say right from the get-go that not all measurement and instrumentation systems are created equal. Look, you've got three different here that are just around measuring a distance of something. Now, if you want to measure a long distance, well, a neat way of doing it is using one of these trundle wheel things, a little wheel, and you counting how many rotations that wheel goes around. Now, that's not going to be anywhere near as accurate as our ruler or our vernier calipers, but it allows us to measure a much longer distance very easily. So sometimes we want to measure, what we're choosing to measure is constrained by the distance we're measuring or the precision that we want to measure with. And we'll talk about those things in a bit more detail to come. Likewise, we have a bunch of different ways of measuring temperature here. Now, these temperature sensors vary widely in both cost and size and application. For example, some of these temperature sensors are what we call intrinsically safe. And so they're not going to be able to create a spark or anything like that, which could ignite a flammable gas. Some of them work at much higher temperatures than others. For example, these cheap ones down here are designed for maybe up to 50, 60 degrees or something like that. Whereas some of those other ones are designed for 100 degrees or hundreds of degrees. And so you've got a whole range there, depending on what the application is, how accurate it needs to be, and some of the more interesting requirements around what our application domain actually is. Now, sensors, there's lots of different types of sensors for measuring everything from temperature and force and pressure and flow, sound, all different types of sensors. We can't obviously cover them all in this course. We'll be covering quite a few of them and discussing going into detail about how they actually work. But suffice to say that if there's a physical variable, there's probably some sort of a sensor and maybe multiple types of sensors that we could use to measure that particular physical variable. Let's go through a few different examples. For example, here we have a modern motor vehicle, or at least a sketch of a modern motor vehicle. And you can see there's all sorts of sensors on this vehicle. Everything from wheel sensors to allow us to measure what our speed is, mirror sensors to allow us to measure where that mirror is in or out, but also sensors to allow us to measure, for example, are cars next to us? Is someone passing us and going through our blind spot? Because often cars these days will have a little light up in the mirror telling you that. You've got sensors measuring the position of your accelerator and your brakes as well. Whole lot of different sort of sensors measuring how much fuel you've got. measuring your climate control things, measuring your position of your steering wheel. And don't get me going on driverless cars where you've got sensors measuring the outside environment and looking at what hazards there are, where the lines are in the road, whether the stoplight's lit or whether it's go, are there stop signs, all of those sort of different sensors that make up our modern motor vehicles. Here's another example that's more in line with what civil engineers would use sensors for. Think of a tall building, or maybe a very tall building. You've got sensors right across a building like this. Everything from measuring temperature and temperature at different levels and working out, is it a safe temperature to work in? Is it a comfortable temperature to work in? You might have humidity sensors along with that as well. You might have water pressure sensors to measure, particularly as you get higher and higher and higher, are you getting adequate water pressure in different parts of the building? You've got fire sensors, and there's detailed fire codes about detection and alarming systems within buildings so that people can be evacuated quickly and safely. You've got air quality sensors, because if you're not getting good air movements around, you might have troubles around asthma and people being able to breathe, spreading germs and disease, all sorts of things like that. You might have sensors, particularly for really tall buildings, around building sway, not just for earthquakes, but measuring sway on normal days due to wind speed and things that the building's encountering. You might also have occupancy sensors. For example, if you're trying to create a smart building that's saving energy, you might turn off lights automatically if people aren't actually in a room. And so you might be trying to sense occupancy for that, or maybe occupancy for alarming systems to detect whether someone's entered a particular area, and then you start turning on cameras and monitoring them, or calling security if someone's not meant to be in a particular area. So a whole lot of different sensors there. Another civil style example is around bridge monitoring. And so we have some sensors. This particular one is measuring sway in a particular bridge, but you can have sensors around bridge monitoring for doing condition assessment of bridges, looking at cracks, analyzing that, measuring force across bridges, a whole lot of different types of sensors that can be applied to these infrastructure sort of applications.